Hello, everybody, and welcome back to a new lecture. This week, we're going to be starting a new one-week module on lighting systems. We're in week 11. The readings for this week are going to be a reading from the Ballast textbook that I will have posted on the course module page, as well as chapter 17 in the Bengali textbook, pages 313 through 334. All right, so let's get started. Lighting design is a crucially important aspect of an interior designer's work. Okay, so obviously we have to have good lighting design because people need to see within the spaces that we are designing. If we design something for a specific purpose but nobody is able to see and therefore not able to use it effectively, then the design is not really all that successful. Proper lighting design supports the function of spaces and it allows them to be effectively used for their intended purpose. This module will provide a basic overview of lighting topics. You will go much deeper on lighting in the next course that you will take next year. All right, so next year they have adjusted your curriculum a little bit, and you're going to be taking a acoustics slash lighting course. And it used to just be lighting by itself. Now it has acoustics built in too, but that course is going to go a lot deeper into the properties of light, how lighting works, design strategies for lighting, all of that. It goes really in detail. So as with most of the content in this course, we're basically just going to provide a basic introduction to get you familiar with some of the terminology and the concepts associated with lighting design to give you a good idea so that by the time you hit that course, you will already have a good head start on the content that you're going to be covering. All right. All right. So, who is on the lighting design team? Interior designers may work with other professionals when developing lighting designs for a project. Lighting consultants may be brought into a project when lighting is of critical importance, similar to an acoustical consultant. So, as we talked about last week, when you were working on a lighting scheme for a project, you may have the option to bring on a lighting consultant who is a specialist who will assist you. All right. You could hand all the work off to them potentially, and they would develop the schemes and the plans and then give it to you for review, and you would coordinate with them to figure out what is the best solution. But your project budget may not always allow for that, okay? So usually that's reserved for special situations where lighting is really, really important. Maybe I like to go back to the whole theater example, but just like acoustics is important at theater, lighting is also important. You have spotlights and stage lights and all of that. Um, and maybe that is not your area of expertise, so you would have to bring in some sort of a consultant who knows about that, okay? Most of the time, though, you're going to be the one in charge of um, most of the lighting throughout the project, though. All right. Interior designers may also consult with electrical engineers to overcome issues related to electrical supply and energy consumption. Okay, so that's similar to a lot of other aspects of the project. You'll be coordinating with engineers a lot. Lighting is no different, but it's more so going to be electrical engineers because they're going to be focused on things like power consumption and energy efficiency. So you'll have to work with them to to ensure that what you're specifying is going to work from a energy consumption aspect, okay? So it has to be efficient as well. For a lighting design to be successful, the system should be aesthetically pleasing. support the intended application, and be energy efficient. All right, so we got to make sure it looks good. It has to fulfill its intended purpose. Okay, so if this is meant for a work area, people have to be able to see to be productive. Maybe if it's for like a more quiet space, the lighting has to be dimmer. Whatever the intended application is, it has to support that effectively, and again, it has to be energy efficient. Okay, so now let's talk about the lighting design process a little bit. When approaching a lighting design, an interior designer must first assess the visual requirements for specific tasks and occupants. All right, so you're going to perform your initial assessment. You're going to take a look at who are the building occupants, what is the need of, or what is the function of the space, and what are the lighting requirements that result from the intended user. Okay. Designers must also consider the relationship between natural daylight and artificial light, as well as fixture placement, mounting heights, and light reflectance levels off of interior surfaces. Okay, so this is the reason why they're combining with lighting with the acoustics in the next course you're going to be taking. There's just a lot of overlap between them. Well, what I'm saying here correlates a lot to acoustics. So we have light waves bouncing around a space, just like we have sound waves bouncing around off a space, and they will bounce off of surfaces to varying degrees depending on how reflective that surface is. So your finishes that you select play a lot into how the lighting scheme within the space is working. Okay, so glare is going to be a big issue that you're going to have to contend with. So you're going to have to make sure that the lighting is also working with all the finishes that you're specifying. And then also, you're going to want to blend natural daylighting in as well. Okay, so daylighting, it's good for just the overall lighting in the space, but also it is going to cut down on your energy consumption. So you're going to want to harness as much natural daylight as you can. And we're going to talk about that more in depth in a little bit here. So there are 3 basic lighting types that are going to be utilized to meet the design requirements. And you might be familiar with these terms already, but if not, we're just going to explain them here. So your first basic type of lighting is going to be task lighting. So this uses direct lighting to illuminate the tasks that a person carries out in a given space, such as reading, cooking, and computer work. So anything task-oriented where you're trying to be productive, that's where that specific type of lighting will be implemented. Here in this example, you can see we have a kitchen with some under cabinet lights, and those are installed obviously so you can see when you're cutting vegetables or working in the kitchen, something like that. The next one is ambient lighting. So this uses diffused or indirect lighting to provide a uniform level of lighting within a space. All right, so here's a really good example of diffused lighting. We'll talk about diffused lighting more in a little bit here, but basically if you don't know what diffused means, it means that the light is uniformly spread out. So if you look at the reflections down here, we have a nice, very even reflection. It's not like one like really harsh hot spot. The lighting is very uniform throughout the space. So ambient lighting, this is basically just your general lighting that is filling the entire space with light so that you can see. And then lastly, we have accent lighting. So accent lighting is lighting that's used to create a focal point of interest or highlight an architectural feature. So looking at this example, you can see we have some little plants that are recessed into the wall, and we are highlighting them with little spotlights. Okay, and that just creates a little bit of a focal point. Purely aesthetic. Okay. All right, so now let's talk about the lighting codes and standards. So energy codes and standards set minimum efficiency requirements for new and renovated buildings. Just like we've talked about codes for every other aspect of building systems, lighting is no different. There's going to be codes that govern what can and can't be incorporated into a design on based on a lighting standpoint. So LEED, okay, we talked about LEED a little bit toward the beginning of the course. They're the ones who will award credits or like a recognition based on how efficient your project is. So they will also consider lighting strategies and implementations when they award their credits. Okay, so if you're going for a LEED certification or recognition, LEED award for the project, you will be considering your lighting strategy very heavily when you're going through the design, because that is something that they will look at. Building codes establish minimum levels of illumination within interior spaces. Okay, so when you're designing, you're going to be referring to building codes, and those codes are going to tell you for this type of space it has to be at least this bright, and it's going to give you a value there with a special unit that is associated with lighting. Okay, we'll talk about some of the lighting units here in a little bit, but those are going to tell you how light or how bright at a minimum each space has to be. Building codes regulate lighting efficiency, and they specify permitted maximum number of watts per square foot. All right, so whenever you're referring to a building code in terms of lighting, they're going to talk about watts per square foot. That's the energy usage metric. Okay, so just like it's telling you how bright it needs to be, it's also saying, hey, for every square foot, your lighting system can't go over this wattage per square foot number. Okay, and that's not going to be up to you to calculate. That's going to be something that your engineer you're working with is going to know how to do. Okay, so don't worry too much about that, but just know that the codes, one part of it is lighting levels, but another part of it is energy efficiency and energy consumption as well. Code requirements typically apply to new construction renovations. They usually do not require the removal or alteration of existing systems. All right, so if you were doing some kind of a renovation project and maybe the old lighting system isn't up to code for lighting, you may not have to touch the old system and bring it up to code. Okay, that's not always the case with everything in a building. Sometimes if you're doing renovation, they will require you to go in and actually modify that component of the building and bring it up to modern standards. But with lighting, usually you're not required to. There could be some exceptions to that though. They may have you do like retrofits, so you may have to take an old fixture, maybe it's like an incandescent fixture. Okay, we'll talk about incandescent a little bit here too if you don't know what that is, but maybe they want you to bring that up to modern standards, so you might swap that out for like an LED, which is much more efficient. So, but it's not going to involve usually going in and like ripping everything out and putting something brand new. It's just going to be like slight modifications. The process of meeting lighting system code requirements involves complex calculations and extensive reporting. This is typically handled by an electrical engineer or a lighting consultant. Again, all the hard stuff typically you won't have to worry too much about. It's really just going to be fixture placement, specifying fixtures, and then coordinating with them to figure out, okay, is this actually going to work? Is there anything that we need to change? Fire codes also have an impact on the design of lighting systems. For example, when a lighting fixture is placed in a wall or a ceiling of combustible materials, the mechanical part of the fixture must be fully enclosed. Usually, non-combustible materials must be sandwiched between the fixture and the finished surface. All right, so a good example of this that I can think of, when I was renovating my house, we wanted to put some can lights, so some recessed cans, in the hallway in our second floor. Okay, so when you get to the top of our steps, originally there was just a little surface mounted light there at the top of the stairs, and we wanted to switch that, and we wanted to turn it into a recessed light at the top of the steps. All right, so when we went ahead and did that, we cut our hole in the ceiling, and up there in the ceiling, it was full of blown in insulation, okay? So we inserted our can light, got everything installed. Well, then I was researching this a little bit, and I come to find out that the can lights that we bought and installed into the ceiling were not rated for being in contact with insulation. Okay, so in other words, the housing, the metal housing where all the electrical components are as a part of that unit, they get too hot to the point where it could actually catch anything combustible around it on fire. Okay, so that was an issue. So I ended up having to go in and remove those and put in a different type of fixture that was rated to be up against the insulation so that there wouldn't be any problem and I wouldn't have to worry about it getting too hot and possibly catching that insulation on fire. So that's something that you're going to have to consider too when you're specifying material or specifying lighting fixtures. Where is this lighting fixture going to go? Is it going to be up against something that is combustible? If so, has it been rated to be able to be up against whatever that material is, okay? All right, so now let's talk about the standards. So basically, standards are developed and set by a variety of authorities. These standards are then adopted and enforced by building codes. Okay, so you're going to have organizations that create specific sets of lighting standards and guidelines, and then the code enforcement agencies, so the building code people, they will adopt those standards that are developed and they will enforce them within the building codes. All right. So here's a little table from the textbook that breaks down the different organizations that develop the codes and the standards. All right. So these should have all been things that you have talked about in your codes course. So you can just read through these. You should be familiar with these names. All right, so let's talk about accessibility and safety requirements now. Lighting design strategies are also influenced by the ADA accessibility guidelines. Okay, so you should be familiar with ADA. Wall-mounted lighting fixtures, so sconces, mounted between 27 inches and 80 inches above the finished floor, must meet the ADA maximum 4-inch projection limit where applicable. So if you look at this picture here, this is also from the book. If we have something sticking out from the wall, all right, and we're going to have somebody who's disabled walking through here, let's say it's a blind person, they can't see and they're really close to the wall, you cannot have whatever that fixture is sticking out past 4 inches from the finished face of the wall, or else it becomes a hazard that they could bump into. All right, it depends though. If this is a certain height above their head, maybe, then it's not as big of a deal. Okay, so right here you can see like 80 inches. That doesn't become an issue anymore because they're not able to bump into it anymore though. But if it's between 27 and 80 inches, so this range, that is where this 4-inch maximum becomes applicable, and you're going to have to consider that so that nobody is accidentally bumping into it and injuring themselves or even damaging the fixture. All right, so lighting fixtures are also rated for use in damp locations, such as outdoor uncovered areas. If a light fixture can be used in a damp location, it will have a label that says suitable for damp locations. Okay, so when you're specifying things, let's say you have to specify something that's going to be used in a wet area, or maybe it's just outdoors where it's not covered, then you're going to want to research and make sure that it is rated to be used outdoors so that nothing goes wrong with it and it is effective. All right, so moving on, we're going to talk a little bit about the physics of light itself. This is going to be sort of reminiscent of what we talked about last week with lighting or acoustics. a lot of it, like I said, is very related. Okay, so they work in much the same way. Light and sound are very similar. All right. So the angle at which a wave of light reflects off a surface is equal to the angle that it strikes the surface. So this is known as the angle of incidence, and this is something we talked about with acoustics. Again, you have a light wave bouncing off of a surface, and the angle that it's bouncing off is going to be the exact same degree as the angle that is striking that surface. All right, so the type of reflections that we have with light waves. So first we have a specular reflection. This is a reflection off of a smooth surface, such as polished glass or stone. The light waves are going to remain fairly concentrated as they are leaving the surface. Okay, so it's hitting the surface and it's bouncing off, and those light waves are not going to be affected too much by it because the surface is very smooth. So they're going to remain pretty much intact as they are leaving that surface. Specular reflections are going to produce harsher lighting conditions such as glare. Okay, so we'll talk about glare a little bit. And then we have diffuse reflections. So a diffuse reflection, this is a reflection off of a rough surface. Okay, so light waves are scattered in all directions and they produce more comfortable lighting conditions. Okay, so here you can see is a specular reflection. We have a very smooth surface. The lighting waves are coming in and they are leaving, and they look almost identical. So there's not much of a change after they are leaving that surface. But here we have a diffuse reflection. So we have some sort of a surface that is very rough. The light waves come in, and when they hit that surface, they bounce in all directions. So they scatter and they go everywhere. Right, so if you remember back to that one image I showed with the ambient lighting where I said this is a very evenly distributed lighting within the space, that was an example of diffuse lighting. So I'm just going to go back to that really quick. So if you look at this, on this light fixture here, they have a panel that is installed over top of the actual bulbs. Okay, so this flat panel, and the panel has a coating on it that is very rough. Okay, maybe it's like a sandblasted finish, but what that finish does is that causes all the light waves to scatter in all directions, and that's what creates this nice uniform lighting. So if that surface that was installed over top of those lights was just like a sheet of glass, that's when you're going to start getting these very harsh reflections where you could actually see the light bulbs on the floor. All right. So that's sort of the difference between diffuse and specular. Right. When we're designing, usually we want things to be diffuse so that they're not super concentrated and they don't produce glaring reflections. Okay. Here's another example of that. So let's say you had your computer, and on your computer, whenever you buy it, usually you'll have the option to get it with a glossy screen or a matte screen. Okay, so glossy screens are usually worse because they produce these harsh specular reflections. So you can see basically everything is perfectly reflected in the screen here on the left, but here with a matte finish, everything is going to be diffused and you don't get those harsh reflections, and it's a lot easier to see the content on the screen. Okay, here's an example of the same thing with flooring. So you can see we're alternating with very polished flooring and a very matte flooring, and the very polished flooring is reflecting a lot of this light that's coming in, and it's creating some glare that could bounce into your eyes and make things kind of uncomfortable. Okay, so again, that's just something you have to consider with your designs. Whatever the surfaces are, horizontal surfaces like floors or countertops, how close are they to direct light sources that are going to be causing light waves to bounce off and into somebody's eyes? All right. Lighting units. So when we're talking about lighting and we're measuring the intensity of lighting, we have a bunch of different units that we can use to describe what is happening with the light. So I'm not really going to go too in depth on this because, again, this is a topic for your future class. You will go very in detail on these things, but here's the chart from your book just so that you can be familiar with them. The ones that you're going to hear the most are foot candles. Okay, so right here, foot candles, also known as lux, and then lumens. Okay, so foot candles and lumens. Just be familiar with those terms, and you can read the descriptions of all of them. They're all very technical. Okay, so I'm not going to get too deep into that. All right, light and color. Color temperature. So this is simply defined as a way to describe the lighting appearance provided by a light source. The textbook defines this in a very technical way that doesn't make a lot of sense unless we would get too deep in the weeds on it. So it's just the color of the light that's being put out. All right. Now this is going to be measured in degrees Kelvin. Okay, so whenever you see this little K at the end of a number, that is Kelvin, degrees Kelvin. And here's a typical color temperature scale. So on the left, we're going to have our warm colors. On the right, we're going to have our cool colors. And actually, this is a little bit counter what you may think. But if you're familiar with how like heat and temperature works, the hotter that something is, the cooler its flame will be. All right, so if you have just a campfire, that's going to be like an orangey color, the color of the flame. But let's say you are welding something with a welding torch, that is much hotter than a campfire. But as it gets hotter, the flame is getting lighter, or it's getting cooler and cooler in color. So it's becoming white and then even sort of a blue shade. Okay, so you can see as the degrees go up, it's actually getting cooler. Okay, so like at 5,000 degrees, we're at like a blue color, and that is considered cool. And then a warm color is actually a lower temperature. Okay, down here at 2,700 degrees. So around that, we're going to get like a warm white sort of hue from the lighting. So here's kind of an example of what that sort of light bulb would look like in a room on this fixture. Here in the middle, we have sort of our neutral. So this is like a cool white. It's not really warm. It's not really cool. It's right in the middle, and that's just going to produce a nice neutral shade within the room. And then our daylight up here is more of a blue color, and that's going to cause a bluish hue to be cast within the room. All right, so just remember that the color of light is inversely related to the temperature. Okay, so as we are getting hotter and hotter temperatures, we're getting a cooler and cooler color. As we're getting lower temperatures, we are getting a warmer color. Okay? All right, glare. Glare is a result of excessive contrast or of light coming from the wrong direction. It can occur due to daylighting or as a result from a lighting fixture selection and location. Okay, so again, we talked about glare a little bit, but this is something you have to think about when we're designing. We have to consider where we're placing things in relationship to natural daylight coming in through windows. That is going to be the biggest source of glare within a space. But then also, we have to consider light fixtures, okay, and where we are placing them, because light fixtures themselves also are going to be sources of glare within the space too. So we're going to have to make sure that whenever we are locating light fixtures within our design, we're not accidentally putting them in a place where we are going to be creating glare ourselves from our design, okay, because that would be really bad. Interior designers must be conscious of glare sources within their designs to prevent visual discomfort of building occupants. For example, avoid using reflective materials in areas that are subjected to direct sunlight. Okay, so we have natural daylight streaming into the space, and we have a really polished, nice polished concrete floor, but at certain times of the day when you walk through there, the light just bounces off of that directly into people's eyes and it makes them very uncomfortable. We have to consider that, and if we do want to use those materials, we have to find some way to treat it. So maybe there's some kind of a window treatment we can apply that can be closed during the daytime when that harsh light is coming in. Okay, so anytime you do something knowingly and you know that you could produce a problem like glare, you're going to have to find some way to deal with it within the design in a different form. Okay, so again, window treatments, something like that. Glare can be caused both by natural and artificial lighting conditions. Interior designers should orient workspaces away from sources of glare and should select fixtures that can minimize glare. All right, so certain fixtures in and of themselves are they produce glare more so than others. So again, if it's a fixture with a lens on it, so a lens being sort of that surface material that I showed you previously that's causing the diffuse lighting, if the lens is like really polished and it doesn't really diffuse the lighting, then it's going to produce more glare than something that is more diffused. So you may want to consider that when you're selecting a light fixture to use. Is the light fixture going to produce itself going to produce glare a lot? And if so, if it is, you might want to consider the arrangement of people in the space depending on what the function is. Okay, so if it's like a workspace like this example, and you have something up here that's producing a lot of glare, you're going to want to consider the way that you're laying out these desks and orient people sort of away from them so that they're not looking directly into that light source. Okay. This is something I'm going to mention here in a minute. We're not quite to it yet, but ideally you want to give people control over like task lighting in their spaces, because it gives them a greater sense of control, but also it's going to just allow them to place that task lighting wherever they want, so you don't have to worry as much about creating a glare. Okay, if there would be a glare, they can easily just reposition that light fixture and it's not as big of a deal. Okay, but if you have it sort of baked into the lighting system itself, there's not really much they can do about it. Okay. All right, daylighting. So natural daylight is an important factor in human behavior, health, and productivity. Windows add views and connect us with outdoor conditions. So daylight is just scientifically proven to be good for your health. It's going to make you more productive if there's more daylight in the space. So as interior designers, we want to strategically utilize natural daylight to improve the moods of building occupants and reduce energy consumption caused by artificial lighting. Okay, so as much natural daylight as we can harness for our design, we want to. Just want to get as much of that into the space as we can. Not only for health reasons, but here, like it's saying, it's going to reduce our energy consumption. Daylighting can save around half of all lighting energy used by buildings, okay, and up to 70% for offices and schools, providing significant reductions in total energy consumption. So clearly daylight is a really good thing to incorporate because it's going to cut down our costs significantly. Daylight with interior spaces is affected by the size and shape of spaces. Taller, more shallow spaces tend to be brighter than lower, deeper spaces. All right. So if you do have a lower and deeper space, maybe a strategy you could utilize is something like a light shelf. So we talked about light shelves previously in the course, but this is basically just a device that you install on windows that are facing the sun. So as the sun is coming in the winter months, maybe it's able to penetrate deep into that space naturally, but as the sun rises in the summer months, it has more trouble getting deeper into the space. So that's where we can use a light shelf, and it's going to cause the sunlight to reflect deeper into the space. All right. All right, daylighting design process. Electric lighting should be developed as a supplement to daylighting. So daylighting, that is our concern first and foremost. Again, there's just so many benefits to it, so we want to harness it as effectively as we can. That should be our top priority. And then whatever the daylighting cannot handle, we want to supplement it with artificial lighting, okay, as a backup, sort of. So that should be our secondary focus. Usually daylighting is used for ambient lighting. So again, ambient just being the natural, the general lighting within the space that is filling it. So it's used for ambient lighting with user-controlled electric lighting for task lighting. Okay, so things task-specific where we need greater lighting levels to see what we're doing. That's where we're going to incorporate some electric lighting to bump up those light levels. Daylight can be introduced into a space using side lighting, such as windows, or top lighting, such as skylights or clerestories. Side lighting is effective for desk tasks. Okay, so if you're working on a desk and you have a window, that is going to be really good for giving you nice, ample lighting to see what you're doing. Top lighting is going to provide uniform ambient lighting and more light per square foot with less glare than side lighting. Okay, so if you have the ability to incorporate some top lighting, that might be a good thing to do because it's going to give you just a nice general overall lighting within a space, and it's not going to produce as much glare as you would from the side. Clerestory windows provide balanced daylight throughout changing seasons, better than skylights do. So a clerestory window, if you remember, these are just windows that are really high up, almost near the roof, and those are going to give a lot better balanced lighting throughout the year than you would get with a skylight. So it's going to be more consistent. So if you can incorporate clerestories, that could be a good thing to do in a building design. Electric lighting. Okay, so now we're going to actually talk about some of the artificial lighting sources. The goal of electric lighting design is to create an interior environment that is both functional and aesthetically pleasing. Okay, so that's pretty much our goal with anything interior design related. It has to be functional and it has to look good. Electric lighting design process. Interior designers will typically prepare a lighting plan and schedule that indicates fixture locations and selections. Okay, so if you look down here, you should be familiar with this plan. I've already discussed it several times, but you're going to be producing a plan that shows lighting locations. Typically, this will just be on the reflected ceiling plan. In some cases, you may indicate these circuits. Usually, that's something that an engineer would do or a lighting specialist. You typically would not indicate those as an interior designer, but you might. But this is just a typical sort of electrical and lighting plan. Interior designers must coordinate with engineers to determine the effects that the lighting system will have on electrical loads. All right, so we've kind of touched on this already, but again, you'll be working with electrical engineers because you have to consider the energy usage factor as well, okay? And they will be the ones who will help you out with that. Okay, so lighting design considerations. High levels of illumination are typically only used in areas where tasks are performed. Ambient lighting is used for most areas for general levels of illumination. Okay, so you're primarily going to be focusing on just general lighting within the space, and then if there's something specialized that needs additional lighting, that's when you're going to go in and specify specific fixtures that are focused on task lighting. General lighting levels should be at least 1/3 as high as task lighting levels. All right. So task lighting is going to be brighter. You're going to want this. The general lighting should be at least 1/3 as bright as whatever the task lighting is going to be, so that you know that people have enough light to just see whatever they're doing as they're moving around through the space. Accent lighting should not be greater than 5 times the ambient level. Okay, so if we have anything that is highlighting a feature, like maybe a piece of artwork with a little accent light, You would not want that to be 5 times the just general lighting level within the space, because that is going to not look so good. It's just going to be too bright. You want to avoid it being 5 times the level. For task lighting, interior designers should consider usable or user controllable lights that can be used based on the needs of each individual. So this is what I mentioned a little bit ago. I said we're going to get to it. This is going to provide occupants with a level of control over their workspace and is less complicated to incorporate into a design than using integrated task lighting. All right, so again, if you're going to bake the task lighting into the system and people have a problem with it, they don't, it's too bright or it shines in my eyes, then you have a problem because there's not much you can do to change it. But if you go ahead and you say, well, I'm just going to give everybody their own desk light and then they can use it however they wish, people like that a lot more because it gives them more control. They can customize it to their liking. They can place it wherever they want. And also, that's just a lot easier on your part as an interior designer, because then you're not specifying additional light fixtures into the design that are, one, going to raise the energy consumption, and two, all the installation with those fixtures as well. It's going to be more energy efficient because people can turn those on and off as they please, and also they can just customize them to their liking. So that's something you should take into consideration. Light fixtures should have a scale that is appropriate for the space they are in. For example, fluorescent light fixtures greater than 2 by 4 feet should not be used in ceilings lower than 10 feet without incorporating a surface pattern to minimize their apparent size. So whenever we're selecting fixtures, we want to make sure that they're appropriate for the size of the space they're going into, or else they're not going to produce the level of lighting that we're going to need. Okay. Interior designers should avoid creating unnecessary wall lighting patterns that can become unwanted visual elements. For example, hot spots caused by recessed downlights that are too close to walls. So here's an example of that I found online. If you're creating some kind of like an accent lighting scheme, you want to consider the placement of those. If they're too close to the walls, you might get these like weird little shapes, and that could be a distraction, and it could cause an unwanted like visual artifact on the wall. So you want to consider the placement of the fixture so that you're not making something that kind of looks weird. Okay. All right, so now let's talk about electric light sources. So these are the different types of light fixtures that you can incorporate. There are a wide variety of light source types on the market that can be used for interior spaces. Up until recently, the most common light source for interior spaces was incandescent lights. However, light-emitting diodes and compact fluorescent lamps have been taking over due to their increased energy efficiency and longer lifespan. Okay. So first, we'll talk about incandescent lamps. An incandescent lamp, before I get into this is basically your common light bulb, okay? Now, I don't know about you guys. Let's see, you're probably about 6 years younger than I am. When I was growing up, these were the main light bulbs that we were using. And then compact fluorescents started to take over. So those are the ones that sort of look like spirally light bulbs, and those kind of became the norm. So maybe when you were growing up, those were more so the norm, but for me it was always these incandescent lights here were the norm, but these are kind of being phased out because they're not very efficient, and there's a lot better things on the market now. So this is known as an incandescent light. Incandescent lamps create light by heating up a filament which glows when it is hot. So the filament is this tiny little string-looking piece right here in the middle, and you have these two metal pieces that are going to that the electric current is running through. So it's sending the current through that filament, and as the current goes through, the filament heats up and it's going to glow, and that is what produces your light. So they emit a warm color of light. So if you think back to our Kelvin chart, they're very much on the warm side. Up to 90% of the electrical energy that is used by an incandescent lamp is lost to heat, and only the remaining 10% is emitted as light. Okay, so that's a pretty bad ratio. It's using up all this energy, but only 10% of the energy it uses actually gets emitted as light. So that means that these light fixtures are very energy inefficient. All right, and also the heat that is emitted can have an impact on a building's cooling load. So if you're using a lot of these, they're actually putting out that heat into the environment. So all that energy they're using, 90% of that is being lost as heat to the environment, and that's actually heating up the air within your environment. Okay, so if you have a lot, then it could actually start to impact the building's cooling load. So the building then has to work overtime to compensate for all these inefficient light fixtures that are making the space too hot. Incandescent lamps are being phased out due to their lack of efficiency, right? So we're moving more toward LEDs and CFLs, compact fluorescents, right? So fluorescent lamps, this is what I meant with compact fluorescents. Here's the sort of spirally version of the light bulb. I remember when these came out, I always thought they looked really cool just because they were so kind of weird looking. All right. Fluorescent lamps can come in two basic types, linear and compact. All right, so here's the linear over here. Here's the compact over here. Linear fluorescent lamps have a tubular shape. They are commonly used for general purpose and task lighting in offices and utility spaces. They work by using an electrical current to vaporize a small amount of mercury. All right, this gets really technical. Don't worry too much about it. Just trying to explain the way that this works. The mercury discharges ultraviolet light to phosphor that coats the inside of the glass tube. The phosphor coating then glows. So within the glass here, this white coating, it's actually a white coating inside the glass. If you were to break one of these open, you could actually take your finger and rub that coating off, and it would just become a just clear glass. So that coating is a phosphor, right? And when the mercury that's within here gets excited from the electrical flow, it's going to cause UV light that is going to bond to that phosphor coating, and it's going to glow. All right. So they're available in many color temperatures, ranging from soft white to daylight. So usually these light fixtures will be on the cooler side. Usually not going to have a fluorescent lamp that produces a very warm light. Okay, so you know, they're going to be cooler. Usually I like to think of them as kind of like a depressing color of light. I usually don't really like the light that's put out by fluorescence. Usually it's like too cool for my taste. But you can get them in a relatively neutral color temperature. So like in my basement, for example, I have some fluorescent lighting tubes, and I got them in a very neutral, so it just produces just a very plain white color, and that works just fine, and it produces just a good task light so I can see what I'm doing down there. They're available, I just said that. They use a fourth of the energy that incandescent lamps use. So they're obviously a lot more energy efficient. That's why they've been moving more toward these compact fluorescents, because if you compare that to just a regular old incandescent light bulb, it's going to use a quarter of the energy that the incandescent bulb uses. Okay, so obviously that's a lot better. High intensity discharge lamps, also called HIDs, these generate light by discharging electricity through a high pressure vapor. Okay, so basically that's some kind of a chemical that is within there, and it's sending a current through it, and that it's then causing a chemical reaction that's causing it to glow. Vapors can be composed of mercury, metal halide, and high pressure sodium. Metal halide lamps are the most common types of HID fixtures, and these are commonly used for industrial plants, gymnasiums, and outdoor recreational fields. So if you think of really just big open spaces like a warehouse or something, then they have to put a ton of light out to light up the space. That's where they're going to use these high intensity discharge lamps because these can throw out a ton of light. Okay, so or like at a soccer field or a football field, those are going to be HIDs that are lighting up the space just because they put out a lot of light. Okay, light emitting diodes, so LEDs, you're probably pretty familiar with this term because they're used for all kinds of stuff, all kinds of electronics, but more and more recently they've been used for just regular interior lighting. Okay, LEDs are quickly becoming the most popular choice for interior lighting applications. They work by passing electric current through a semiconductor. LEDs themselves are small, so LED fixtures are assemblies of several individual LEDs. So this is what an individual LED looks like. If you were to go buy these at the store, you can get them in all kinds of different colors. But then here's an example of like a Philips Hue bulb. So maybe you've used one of these smart bulbs before, but these are LED lights that actually have the ability to produce light of any color. Okay, so the LED it doesn't have a plastic coating like this that's a specific color. It actually has the ability to change the colors that it's outputting. And these are easy to install. They're long lasting, roughly 50,000 hours, and they radiate very little heat, and they are very energy efficient. And like I said, they can output light in any color, so that's really cool. All right, and that's becoming the new standard. All right, so let's talk about architectural lighting. So when I say the term architectural lighting, we're referring to equipment that is an integral part of the building. Okay, so any sort of lighting solution that we're integrating into the design of the building, not just like a light fixture that's attached to the building, that is known as architectural lighting. So if you've heard some of these terms before, we have cove lights, cornice lights, coffer lights, valances. All that is considered architectural lighting. So here's the descriptions and you can read them. I'm just going to visually explain these. So here's a cornice light. This is when you have a light around a perimeter of a space, and you can see we have some kind of a screen here, some kind of a screening device. Maybe it's a portion of wall that's coming down from the ceiling. And then behind that, we have this little cavity, and we have a light fixture up in there. And when we turn it, it's creating a nice glow around the perimeter of the room. Here's an example of a valance light. Okay, so very similar to a cornice, except it is not up toward the ceiling. This is maybe more like a ribbon that's going around the room, and it has some kind of a screen that's sticking out from the wall that is blocking the light. A cove light is also up toward the ceiling, except it has a screen below it that is preventing you from seeing the light from below, and then the light is being cast out toward the ceiling. And then here's an example of cove lighting around a recessed coffer. Okay, so that's what that looks like in a section, and then this is what that would look like in a space itself. So here's an example of cove lighting, and this is just when you have lighting up inside the ceiling that is creating a nice soft glow. Okay, so this is what I mean when I was talking about architectural lighting. It's lighting that's actually integrated into the design itself. And the lab that we do this week is actually going to be showing you how to build a ceiling like this inside Revit, how we can incorporate cove lighting into our design using Revit. All right, so light distribution types. So different light fixtures output light in different ways, okay? We have all these different ways of distributing the light waves, okay, in different fixtures, do it in different ways. So first would be direct concentrating. This would be like a, let me think here. If you've ever seen those simple like Edison bulbs that are just hanging from the ceiling, that'd be kind of an example of that, where it's outputting light sort of in multiple directions, but it's kind of concentrated in one area. Direct spread. This is where you have sort of a like a shielding element on the top, and then the light is being sent downward, and it's being spread out in multiple directions, but only downward. Semi-indirect. This is where most of the light is being pushed downward, but then the fixture is also sending out light a little bit out the top as well. Not as much as what's going down though. General diffuse is where the light fixture is outputting light in all directions equally. Semi-indirect is where the light fixture is pushing light mainly upward toward the ceiling, and then that light is also cascading downward. Okay, so it's not outputting it downward, but the light naturally is being reflected down. And then indirect is where the light is just going straight up, and none of the light is making its way down below the light fixture. Okay, so these are usually like sconces, and the light is just being pushed straight up toward the ceiling. Then an indirect or direct indirect, this is going to be where you have light that is going upward and downward equally. All right, this would also be like a sconce would produce this type of lighting. Right, here are the descriptions of them. You can go ahead and read those. I'm not going to read through them. Now we're going to talk about different types of light fixtures themselves. This is going to be the last thing we touch on in this lecture. So flush mounted fixtures, these are attached directly to the face of the ceiling. They're common in residential entryways. So here's some examples of those. I'm sure you've seen these before. Recessed downlights. Now I'm sure you've seen these before because these are used pretty much everywhere. Fixtures are recessed into the ceiling itself. These are a popular general lighting solution for commercial and residential applications. Pendant fixtures. So pendant fixtures are suspended from the ceiling. The suspension length can be adjusted. Okay, so we can make these lower if we want to, or we can adjust it and make them higher up, more toward the ceiling. They're commonly used for task lighting in kitchens and restaurants. Track mounted fixtures. Fixtures are attached to a linear track. Okay, so here's our track. Here's our fixtures, and we can adjust the spacing however we see fit. So if I want this one to be more down here, I can move it. These are kind of nice because they're just easily customizable and they're easy to install. They're commonly used for accent lighting in residential spaces. So in my house, for example, I have track lighting in front of a big painting that I have in my living room, and I have these. I have like these three heads here, very similar to what you're seeing here, and I have them shining directly on that painting to highlight it as a feature. Wall washers. So these are floor or ceiling mounted fixtures that graze walls with diffused lighting. Okay, diffused again, very spread out and even. They usually are used to create accent lighting and focal points. Okay, so you're probably going to see this maybe in higher end spaces where they're trying to create like a dramatic effect. And then lastly are sconces. So these are wall-mounted fixtures, and they are commonly used for task lighting in residential spaces. So something like this you might see on either end of a bed, over top of like an end table to give you nice task lighting. All right. So that is going to be it for the lecture. That was the last thing that we had to talk about. Go ahead and read your chapter. It goes a lot more in depth, as always, but these are just the main points that I pulled from the readings. But make sure you read through it and you understand everything that's in there. If you have any questions, go ahead and reach out to me, and I will get back to you.